Even since we were kids, I think most of us could agree that the first thing that comes into our mind when we hear the word engineer is someone who builds the structure of a house, a building, roads, or bridges. However, engineering is a very broad topic, branching into many different fields. So today, we're gonna focus on civil engineering. I am Eliza Delphine.
I am James Michael Rose.
Jor Gabriel Marilang.
I am Arkenji Empeñaso.
Here's the definition of civil engineering. First, let us define engineering. Engineering is a field of study and practice that involves applying scientific, mathematical, and technical knowledge to design, create, and maintain systems, structures, devices, and processes. It involves a combination of application of creativity, resourcefulness, and problem-solving abilities to turn concepts into real, societally beneficial solutions. Now, to better understand the concept of civil engineering, let us have a breakdown of these two words. According to the Merriam-Webster's, civil refers to activities, needs, or civic concerns which involves the general public. And engineering is derived from the word engineer, which itself dates back to 1390. An engineer was described as someone who is working on engines, more especially a builder of military engines. And according to the International Association of Engineers 2016, the term engineer originated from the Latin word ingenium, meaning cleverness, and ingeniare, meaning to contrive or devise. And in 1750, the term civil engineering later was established by John Smithson as the design of civilian structures matured as a technical discipline, as well as a way to distinguish between those military engineers who work on weaponry and defenses with those working on civil projects. Therefore, civil engineering is the planning, building, and maintaining of both public and private infrastructures such as dams, bridges, aqueducts, canals, highways, power plants, sewerage systems, buildings, houses, and many more, built to address the particular needs and concerns of the community.
Civil engineering is a diverse and ancient field that involves various technical skills. It focuses on planning, constructing, and maintaining infrastructures like roads, bridges, and tunnels. Due to their important duties, civil engineers undergo training to acquire skills and education. They must stay updated with emerging technologies and often need a bachelor's degree for the profession. Civil engineering is an undergrad program that blends core engineering courses with electives in specialized fields like construction, geotechnical, structural, and more. The degree takes 3 to 5 years and leads to a Bachelor of Science or Engineering. Students study math, engineering, statistics, fluid dynamics, and architectural design through lectures, training, and fieldwork. The program teaches applying math and science to solve real-world problems considering environmental, financial, legal, and ethical factors. Civil engineers uphold professional integrity, prioritize human well-being, treat all parties honestly, enhance engineering reputation, and support technical societies in their roles. When working in construction, whether as civil engineers, site engineers, or in other roles, it is important for them to know about the discipline and different major subjects in civil engineering.
So to continue, I will be presenting to you the major subjects in civil engineering. First is concrete technology. So concrete technology deals with the behavior of new concrete aiming for complete compaction. It includes advanced types like lightweight, high strength, and underwater concrete, often using additives like viscosity enhancer. So next is surveying. Surveying involves accurately measuring the Earth's surface on a large scale. So this process includes collecting, interpreting, and applying measurement data to determine relative position and size based on established standards. Next is structural analysis. Structural analysis calculates the impact of loads on structures. So it is vital for engineers since it ensures a thorough understanding of load paths and effects on design. So this analysis confirms safety under expected loads during design, testing, or post-construction. factoring in materials, shape, and applied forces. So next is transportation engineering. So transportation engineering is a discipline of civil engineering that focuses on planning, designing, operation, and maintenance of transportation networks in order to help cities become smart, safe, and livable. So next is environmental engineering. Environmental engineering merges civil, chemical, and biochemical sciences with project management addressing global environmental concerns through detection and ethical solutions. So next is fluid mechanics. Fluid mechanics studies fluids in static and dynamic states. So analyzing forces, movement, and state in a continuous medium. So it recovers surface tension, fluid statics, flow in enclosed bodies, stability, and more. So fluid mechanics underlies various human actions. Next is strength of material. So solid mechanics studies how solid bodies react under various loads, explaining stresses, strains, breaks, and fractures. It aids in researching, designing, and determining materials suitable for specific application. So next is water resource engineering. Water resource engineering manages and conserves abundant water resources, involving strategies for human, plant, and animal consumption. It also covers water control in activities like irrigation, waste disposal, and canal development. So next is building planning. A building plan is a graphic representation of a structure and its components. So it encompasses site plans, floor layouts, structural details, elevations, electrical or plumbing design, and landscape drawings. So next is heavy construction and project management. So construction project management involves guiding, overseeing, and controlling a project from start to finish. So the ultimate aim is to fully satisfy the client's functional and budgetary requirements. So this covers various project types including commercial and residential constructions. So next is building materials. Understanding building materials is essential for constructing secure, effective, and durable structures. So this knowledge is crucial for civil engineers and construction professionals. So the chapter on building materials in civil engineering covers the full range of available materials. Next is design of reinforced concrete structures. So reinforced concrete includes steel bars within a concrete structure to enhance its strength. So it is created by blending concrete with reinforcing bars. So next is design of steel structures. In civil engineering, design of steel structures involves creating safe and efficient buildings using steel as primary material. So steel's strength, ductility, adaptability, and durability make it a preferred choice. So it is commonly used in buildings, bridges, towers, and industrial structures. Next is earthquake engineering. Earthquake engineering studies how structures respond to earthquakes and their interaction with the ground. It aims to design and construct structures that adhere to building codes, minimizing earthquake damage without excessive cost. Next is estimation and cost analysis. In civil engineering, estimation refers to projecting project cost by comparing it to completed similar projects. Next is bridge engineering. Bridge engineering involves surveying, planning, designing, analyzing, constructing, managing, and maintaining bridges that withstand loads. So lastly, engineering mathematics. Engineering mathematics applies mathematical theory, practical engineering, and scientific computing to solve complex real-world problems and address modern technology challenges.
Now let us define civil engineering in the context of profession. Do you believe that civil engineering is everywhere? Well, just look around you. Most of the things you see in your surroundings are one way or another a result of civil engineering. From the structures we live in, learn, and work in, the water we drink, the transportation infrastructure we use, and the sewage system that keep our cities going, all of this exists because of civil engineering. In fact, civil engineering is considered to be the most extensive and the oldest profession in the engineering field that encompasses a wide range of occupation, industries, skills, and people. It involves the planning, designing, constructing, and maintaining different types of infrastructures and public works like transportation, water treatment, governance structures, public amenities, and other sizable projects that serve the general populace. Now that we got the general idea of what the civil engineering profession entails, let us now answer the question, who practices this profession? Well, we call these people civil engineers. They are highly skilled and trained professionals who plan, design, construct, and maintain different types of infrastructure such as buildings, bridges, roads, railway systems, flood and coastal protection, water supply systems, drainage systems, airport, harbors, and dams, among others. During construction, civil engineers are responsible for ensuring that all processes run smoothly and that all works are done on time, within budget, and are in compliance with safety regulations, ethical considerations, and design specifications. With the broad scope of the civil engineering profession, it can be further divided into different specializations. The first being the structural engineering. Structural engineering are responsible for the analysis, designing, and computation of load-carrying materials of an infrastructure. They also ensure that certain infrastructure is durable, stable, and can last for a long period of time. Civil engineers are not only involved in designing, planning, and construction of buildings, but they are also involved in the field of environment. Environmental engineers study water, soil, and air pollution problems where they develop possible solutions that are needed to solve the issue. Next is geotechnical engineering. Geotechnical engineering is a field of civil engineering that primarily focuses on the behavior of engineering of earth materials. They use their knowledge of geology, geophysics, and hydrology to test soil and rock mechanics, evaluate the properties of soil, investigate construction sites, and design foundations that reduce potential risks such as landslide. Lastly, transportation engineering is a field of engineering that specializes in the maintenance of transportation in order to provide a safe and livable communities. Any systems that move people and goods from one place to another, such as railways, from public transportation systems, highways, and more, is under the transportation engineering. Aside from constructing transportation infrastructure, they are also tasked to enhance traffic flow and, most importantly, ensure the safety of the passenger. That is all for the definition of civil engineering. And in behalf of my group mates, thank you very much for listening.